Okay, let us discuss this problem. This problem is quite interesting problem. So draw the diagram of the molecule and then we'll go for the next. So you have CH3O, CH2, CH3, CH2Cl. So this is the molecule that is given to you. So you have this molecule. Now if you see on this molecule, this carbon is chiral. This contains hydrogen, this side CH3, this side CH2Cl. This side CH2O CH3. So we have this carbon as a chiral. I can show something like this. CH3H. This side we have CH3. This side we have H. This side CH2Cl. This side we have CH2O CH3. So this carbon is basically chiral. Are you getting or not? Now what we are saying. So let us first decide the priority order. Now this is carbon. This is oxygen. Here also you have carbon. So this carbon is attached to carbon, carbon, carbon. Go for the next. First point of difference. If you go this side, you have carbon attached to chlorine. So this will get priority order 1. This carbon is attached to 2. So oxygen. So this will get priority order 2. This carbon is attached to hydrogen. So this will get priority order 3. So we are deciding priority order 2 nomenclature for R and S. Now this problem says write down the structure of R configuration of this molecule. So can I write the R configuration of this molecule? So let me rub this here. So you see what will be the R configuration. R means I have to make clockwise. Let us put the hydrogen on the dash line. If I put the hydrogen on the dash line, I have to put 1 here, 2 here, 3 here, so that I can have a R configuration. And 1 is CH2Cl. So let us put CH2Cl here. 2 is OCH3, put OCH3 here. 3 is CH3, so put 3 here. So now this is R configuration. So this is R configuration. Now if I treat this compound with N3 minus, what do you think? What will be the product? Just see the molecule and give the answer. If you see this molecule has a good leaving group Cl. So what N3 minus can do, because it connects as nucleophile. So this lone pair can attack here and Cl goes out. So basically in place of Cl I can attach N3. So you see you can write your product yourself. Now see you will have this is CH2N3 because I have removed Cl to N3. Now here no change, so OCH3. Here I have hydrogen, here I have CH3. Now let us find the priority order. So this is oxygen, priority order 1. Here I have carbon, but carbon attached to nitrogen. So this is priority order 2. Are you getting or not? So and the last one, did I have done something mistake? Yeah, there is a mistake. I have to add CH2OCH3. This is simply I have written OCH3. This is not correct. So this is CH2OCH3. Are you getting or not? Here also I have to write CH2OCH3. So this is my CH2OCH3. Are you getting or not? So this is CH2OCH3. So what is this? So this is basically CH2OCH3. Are you getting or not? So you see here, this is CH2OCH3 initially you have. So here also you will have CH2O. So this is CH2OCH3. This group that is also CH2OCH3, and CH2O3 has a priority order 2. But now you see what will the priority order now. Let us say this is CH2, this is CH2. Here I have nitrogen, here I have oxygen. So now oxygen will get preference over the nitrogen. So now this will be priority order 1, this will be priority order 2. And this will again priority order 3. So you see what happened. Initially CH2OCH3 was priority order 2, but now CH2OCH3 becomes priority order 1. If I remove chlorine with nitrogen, that is because nitrogen has less priority order of the chlorine, that's why this becomes priority order 2. So oxygen and then nitrogen, and this is carbon. You're getting or not? If you have confusion in the priority order, let me explain again how to decide the priority order. Go for here. If you see there is a CH2, there is also CH2, there is CH2 also, and attached to hydrogen. So no difference. Now let us go to the next. If I go there here, I have a nitrogen, again go to here. Oxygen, I have go here. Hydrogen. So oxygen is the highest, so I will get 1. Nitrogen then 2. And then hydrogen, so I will get priority order 3. Now if you see, what is the configuration? This is 1, this is 2, this is 3. So I will have something like this. So this is anti-clockwise. So this configuration will be S configuration. Now I ask a very simple question. You see, in this problem what we have done, after attack of N3 minus, R has changed to S. R configuration has changed to S configuration. But does the configuration around car1, that is chiral, changes? So very valid question I am asking. Does the configuration around this car1 is changing or not? So I am asking a question. Configuration has changed R to S, or its nomenclature has changed from R to S. But does the configuration about the chiral carbon atom has changed? In the space, does the atom orientation, so for this atom, this is atom and this is atom, is the spatial orientation has changed or it is same? Now see, this spatial orientation is same. You see all are going downside, in this case also all are going downside. So spatial orientation has not changed. So this is from here to here. I have not broken any bond here also. So chiral carbon bond has not been broken. So this is basically, this goes from here to here with retention of configuration. Are you getting or not? So this is going from retention of configuration. So configuration is retained. So configuration is retained. Are you getting or not? But the R changes to S. So what this suggests? This suggests if R changes to S, this does not always mean there is an inversion of configuration. You can always have R changing to S with retention of configuration. This depends upon priority of order of nitrogen. If the going group and coming group both have same priority, in that case inversion, the nomenclature will basically remain same. But if R going group and coming group both are opposite, then R will change to S. So nomenclature has nothing to do with the inversion of configuration. So nomenclature will remain same, R will remain R, or R will change S. It depends upon the going group and coming group. There is the priority of going group and priority of coming group. If the priority of going group Cl minus and priority of coming group are opposite, like in this case, R will change to S. If the priority of going group and priority of coming group are same, then R will remain R. Are you getting or not? So R changes. So I can now say one thing. R changes to S, but does the configuration around the chiral carbon changes? Of course, answer is not. No. So you see, I can say R to S does not mean always inversion of configuration. In this case, this is a case of retention of configuration. So this is a very valid point. People generally think R changing to S is the inversion of configuration. That is not true. R changing to S may be with retention of configuration. R changing to S has nothing to do with inversion of configuration. Inversion of configuration is something like this. I have groups attached this, and after that groups attached this. So A, B, C I have here. A, B, C here I have. So they are oriented towards this face. Now they are oriented towards this face of the ball. So there is a ball. So this is oriented toward this side, initially this side, and now they are oriented toward this side. So left side, another side, right side. So these are inversion. So inversion means your phase of orientation changes. But in this case, there is no phase of orientation that has changed. So this means this is a retention of configuration. We'll discuss the next problem.